Welcome to Teja Statistics for BSc first year and data science. The last unit important questions we are discussing. First of all, definition of the sample. A finite part of the population is known as sample. Sample size. The number of individuals in a sample is known as sample size. It is denoted by small n. A very important definition, that is parameter. Any unknown value in a distribution or a population is known as parameter. Like examples, lambda is the parameter in a Poisson distribution. P comma n are the parameters in a binomial distribution. The sampling distributions we are just discussing here. If you continue with this parameter definition, you can easily understood. Next, the statistic. A group of observations are used to find the value of the parameter is known as a statistic. So what is the statistics in a statistic in a binomial distribution or a Poisson distribution? Let x1, x2, x3 are the n number of observations which are drawn from the population of normal, or we can say that they are the observations of the binomial distributions. So the mean of that observations are said to be a parameter. To find the value of the parameter, that is used to find the value of the parameter, that is n comma p in binomial distribution. So the mean observations are said to be the statistic. In Poisson distribution, if you consider, this is the example they taken. The lambda is the parameter of the Poisson distribution. To find the value of lambda, we can use a group of observations. So x1, x2, x3 and so on xn. Okay, the mean values of these. So that gives the value of the parameter lambda. That is, you can see the observations x1, x2, x3 and so on xn, that is x bar summation xi divided by n. Next, the sampling. The process of drawing a samples from the population is known as sampling. What is this sampling distribution? Let the population of size capital N and draw the samples from the population of size small n. There exist NCN possible samples, and conclude some statistics to the obtained samples is called sampling distributions. Next, very important definition, that is standard error. The standard deviation of sampling distribution is known as standard error. We have some sampling distributions. Let's see what are the sampling distribution. In our syllabus, they asked you to write the only definitions. So sampling distributions are chi-square distribution, T distribution and F distribution, which we can also call small sample distributions also. Next, in continue, let's see the definition of the chi-square distribution. The gamma distribution with two parameters is given by f of x is equals to x to the power of alpha minus 1 into e to the power of minus x given b gamma of alpha into beta to the power of alpha. In this gamma distribution with two parameters, just replace the values of alpha equals to n by 2 and beta equals to 2. the PDF will become f of x is equals to x to the power of n by 2 minus 1 into e to the power of minus x by 2 of gamma of n by 2 into 2 to the power of n by 2. This is the PDF of chi-square distribution. Mathematically, we can write x follows of chi-square of n. So here n or n minus 1 is called the degrees of freedoms. Okay. The mean and variance we can evaluate from the moment generating function. So which you already know, which you already learned in your previous examinations. Mx of t is equals to expected value of e to the power of tx. The gamma distribution with two parameters and the function you already wrote here, the chi-square of f, that is f of x, x to the power of n by 2 minus n by 2 into e to the power of minus x by 2 of gamma of n by 2 into 2 to the power of n by 2, where n is always greater than 2. Okay, so if you calculate the mean value, then you will get the mean value as 1 by 2 gamma of n by 2 is gamma of n by 2 to the power of n by 2. All are the different calculations, they are the constants. So you have the one formula here, 0 to plus infinity x to the power of m minus 1 into e to the power of minus ax into dx whole to the power of, that will brings you the gamma formula, gamma of m divided by a to the power of m. So by substituting that, simply we have got the value of mx of t, and from that we are just observing the mean value, that is n, and mu2 dash, if you derive mu2 dash also, the mu2 dash value will be the second derivative of that the given function, and the mu2 dash you got is n square plus 2n. The variance value is mu2 is equals to mu2 dash minus mu1 dash whole square, which is the value of the 2n for the chi-square distribution. So the mean and variances of the chi-square distribution is n comma 2n. So please remember that up to the definitions and their functions and the MGF values of the given data. Okay, and mean and variance also very important for this. This is about the chi-square distribution. In next session we are going to learn about the t distribution and the f distribution, mean and variance. Before going to complete it, just to see the applications and properties of this chi-square distribution. It is used to test the sample variance, that is single sample variance. Chi-square test is distribution is used for testing independency of attributes. Chi-square distribution is also used to test the goodness of fit. Chi-square distribution is also used to test the ANOVA. Next, the properties of chi-square distribution. The chi-square distribution is always lies between 0 to plus infinity. The chi-square has a single parameter, that is n. Chi-square is positively skewed. The mean and variance of chi-square distribution are, that is n and 2n. The additive property exists in chi-square distribution. The MGF of the chi-square distribution is given by 1 minus 2t into whole to the power of minus n by 2. The shape of the chi-square distribution depends on its parameter n value. So these are the very important properties and applications of the chi-square distribution. In next session we are going to conclude with the f and t. Thank you.
அண்ணன் யாரு